Welcome to this explainer on workplace electrical safety. We are around electricity literally all day, every day, so it's super easy to just kind of take it for granted. But today, we're focusing on how to actually spot and stop these invisible hazards before they strike. This isn't just about checking boxes or following rules. It's about really understanding the physics of the environment you're walking into so you can leave work safe and sound. To get there, we'll quickly run through our agenda. First, the invisible workplace threat. Then, you as a circuit, followed by the be safe hazards, spotting hidden dangers, and finally, acting safely every day. Okay, so we usually picture electricity safely tucked away inside cords and functioning machinery, right? But I want you to keep this one high-stakes question in the back of your mind as we go through this material. What happens when your body becomes the wire? Section 1. The invisible workplace threat. Electricity on the move. To actually spot these hazards, we've got to realize that electricity is essentially a relentless, invisible force, and it is constantly hunting for the easiest path to the ground. Period. Think of it like a battle line. Your copper wires are the conductors. They're eager to move that energy, while those colored rubber coatings are your insulators. Their one and only job is to keep that aggressive energy safely contained. Section 2. You as a circuit, the biology of a shock. Now, things get incredibly dangerous when those insulators fail, because when they do, that energy instantly finds a new conductor. And unfortunately, sometimes that conductor is us. But here's what's really fascinating. Your body's natural armor changes wildly based on the environment. If your skin is totally dry, it's actually a pretty solid insulator. We're talking 100,000 ohms of resistance, meaning a standard 110-volt exposure might just give you a tiny 1 milliamp tingle. But, and this is a huge but, if you have damp, sweaty hands, the physics entirely change. Your natural resistance plummets all the way down to a mere 500 ohms. Let's put that into perspective. That is a 200 times drop, just from a little bit of sweat. You go from having this robust, natural shield to literally rolling out the red carpet for an electrical current. That 200 times drop is exactly what turns a minor buzz into a potentially fatal shock. And if you do end up becoming part of that circuit, well, it's not pretty. Our bodies already run on tiny electrical currents in our nervous systems, right? So when an external shock hits, it sends massive currents pushing through your body that just completely override your internal wiring. It can instantly cramp or freeze your muscles, meaning you physically cannot let go of whatever you just touched. And if the current gets high enough, it can cause respiratory paralysis or fatal heart fibrillation. It literally scrambles your heart's natural rhythm. Section 3. The BESAFE hazards, anatomy of workplace injuries. To make these specific risks easy to remember, safety experts use the acronym BESAF. Let's break it down, starting with B. B stands for burns. This is absolutely the most common shock-related injury out there. When all that electrical energy pushes through human tissue, it generates intense, severe heat right at the point of contact. Next up, E is for electrocution. Now, we use this word casually a lot, but it's important to be precise here. Electrocution specifically means death caused by exposure to a lethal amount of electrical energy. It is the absolute worst-case scenario. Then we have S for shock. This is that sudden, violent physical reaction the exact second your body becomes part of the active circuit. It's that total nervous system override we were just talking about. Moving on to A, which stands for arc flash or arc blast. In simple, everyday terms, think of an arc flash as a localized lightning bolt. It's this sudden, terrifying explosion of energy that leaps right out of the equipment and jumps through the air when a high voltage gap breaks down. Seriously, the sheer power of an arc blast is wild. You don't even have to physically touch a wire to get hurt. Just standing nearby when that energy violently releases through the air can cause catastrophic burns and blast injuries. Rounding out the acronym, F stands for fire. We see this all the time in the workplace, usually from overloaded circuits or failing equipment. Think about a melting power strip. It pulls way too much current, generates uncontrolled heat, and eventually ignites the plastic and whatever else is sitting around it. Finally, the last E is for explosion. This happens when errant electrical sparks happen to ignite a volatile environment. We're talking flammable gases, vapors, or even heavy dust clouds floating around in the air at your job site. Section 4. Spotting hidden dangers, everyday combinations. Knowing the science is only half the battle, guys. we also have to actively hunt for the environmental combos that set the stage for these accidents. The classic example? Combining dampness with a compromised bare wire. Remember how water destroys your skin's natural resistance? If you have a damp floor, a sweaty hand, or even just a spilled drink near a bad wire, you are instantly creating a highly conductive superhighway straight into your body. And it's not just water. Think about the tools you're using. Working on live panels while standing on a highly conductive metal ladder, that creates the perfect, deadly path to ground. If you get a shock in that scenario, the metal ladder ensures the current travels right through your vital organs to reach the earth.
Section 5. Acting safely every day. Your best defense. So, how do we systematically stop this stuff? It really comes down to using the right personal protective equipment, or PPE. Remember our talk about sweat ruining your resistance? Well, PPE, like heavy insulated rubber gloves, non-conductive hard hats, safety glasses, acts as artificial resistance. It puts a guaranteed physical barrier between you and the danger, so even if something goes wrong, the current can't easily get to you.
But I gotta say, the single most powerful tool you have is your mindset. Think safety, act safely. It means deliberately pausing to look for damp floors or bare wires before you start. And hey, if the worst does happen and a coworker takes a shock, acting safely means knowing exactly what to do in that split second. First rule, do absolutely nothing that makes you part of the circuit. So do not touch them directly. Instead, immediately disconnect the power source if you can, and call for emergency help right away. It's all about being mindful and knowing how to react.
So, knowing how easily electricity can bypass your natural defenses and turn you into a conductor, what's the very first thing you're going to inspect differently on your next job site? Because at the end of the day, understanding this relentless, invisible science is exactly what empowers you to take control, stop hazards, and head home safe. Thanks for hanging out with us for this explainer, and stay safe out there.